Hello and welcome to part 3 of a series on Ontology talk on installing the Sigma knowledge engineering environment. In this episode, I show you how to do a little bit more configuration on Sigma, how to start up the web-based user interface, and also show you how to access functions at the command line, including theorem proving. So I had a problem on the first installation I didn't realize until after. So it was a permissions issue. I had, as you can see in the instructions here, opened the permissions to the bin directory of Apache Tomcat, but I hadn't actually opened the permissions on the web apps directory, and that caused a problem when I was compiling with Ant down at the last step. It wasn't copying the files correctly into that directory because the permissions were wrong. So I don't know if that's something that may be just specific with this clean installation on Vagrant, but you may want to try that if you have some trouble activating the web interface. So let me move on to a couple other considerations. So for running under Vagrant, you're going to have to be concerned with port forwarding. Now, I didn't want this to be a tutorial on Vagrant, but I should mention that since I'm discussing the Vagrant installation. So let's just take a look at the Vagrant file, and I'll show you what I mean. So Vagrant, let's see. Gives you, actually let me look at memory also is another issue. You're probably going to need to bump up the memory, so it was set originally to 5,000, I made it 9,000, and that improved the situation a little bit. Here's what I was talking about, port forwarding. So Tomcat runs on port 8080. So when you're accessing Apache Tomcat, the Apache Tomcat web server, which I'm going to show you how to do in a moment, you're going to be accessing the running process on Vagrant. So that's on this what they call the guest machine, right? It's running as a guest on your Linux host. So the guest is going to run on 8080. Now you can configure that, and you could change Tomcat if you want, but it's easier just to leave it at the default. The host, however, is going to recognize it at port 8088. And so you'll see that when we go to start up Sigma and look at it on the web, it's going to be accessing port 8088 so that there won't be a clash if you run it also locally. Then you can run Apache Tomcat locally on your actual physical Linux box on 8080. And so you access the guest process running on Vagrant at port 8088 and any native process on port 8080. Okay, so that's it for Vagrant. And so now let's take a look at actually starting it up. So we're going to go over and start up Vagrant. And you can see here we've got a transcript that shows this port forwarding here just for verification. So port 8080 on the guest machine running under Vagrant will appear as port 8088 on the host. Okay, so there it is. So we've got it started. So let's go over to the Vagrant virtual machine. We are going to change to the user that I created earlier and go to that directory. So there we are. Another consideration for running Tomcat, you don't get the error messages to the screen, you get them to a log. So they go to a file called catalina.out. So let's just show you that. So that's going to be in the directory where you installed Tomcat. So we're going to change to that, and it's in the logs subdirectory. And you're going to get lots of logs, so they can build up after a while. If you're running a server, you're going to need to clean them out every so often, or maybe run a cron job to do that for you. So the file that we care about here, though, is catalina.out. So let's just take a look at the end of that. Okay, and so here's showing where I was testing it earlier and started things up. And you get a lot of messages about what ports things are running on and so forth. But most importantly, for running Sigma, you get all of Sigma's error messages and status messages there. So if something's going wrong, the answer is usually in checking the output of the logs. And it's usually just maybe you made a typo in a an environment variable that points to a directory or something of that sort. Right. So I'm just going to, for now, I'm going to destroy all of these logs so that we don't have any old stuff in there that might confuse us. And that's also a good practice if you're trying to debug an installation. So let's go back to the root, and now let's start it up. So let's do this. And I like to type full paths so that I have those full paths and I can go back to them in the history. If I just do a relative path, then maybe I'll be in a different directory and it won't work. So if I do the full path, that's just a convenience. So you start up Tomcat by, not surprisingly, a script called startup.sh, which is in the bin directory. Okay, so there it is started. And now what I'm going to do is I'm going to go back to my host machine. Let me just give you a good view as to that. Okay, and I'm going to try to access it. So it's going to be on localhost, but it's going to be on port 8088. 8088, and it's the Sigma application, and we're going to log in. Okay, and so there it is. Now the standard login is admin. You can change that if you're running a server, you want a different login. The register a new count is something I've been working on that actually isn't functional at the moment. So I appreciate any help on that, anybody that wants to chip in on making that work properly. All right, so we're going to load up Sigma now at the moment. And this takes a few moments. It's got to load in all of WordNet. It's got to load in all the ontologies that you've specified in your config XML. So actually, let's take a look at what I've got loaded in the config XML. So let's look in the Tomcat. Let's look at the Sigma key directory is where the config XML lives. Okay, and so I just have the moment countries and regions file, so facts about the world, and merge, which is the upper level of Sumo, kind of the original Sumo. Right, so it's just loaded now. And future loads, once you've loaded a particular configuration, will be much faster. The first time it loads, it's got to parse all the files and create a bunch of indexes, but then it saves those out in a Java serialized binary format, so subsequent loads are much faster. Okay, so here it is, running on port 8088. Now my browser is running on my host machine, and it's accessing Sigma on the guest machine. So just to show you a little more about Sigma, so let's look at a graph. Let's look at a graph of object. And here I'm going to show you the GraphViz system running. So it creates these very elegant looking graph representations. Now Sumo is not just a graph. It is a theory in higher order logic, but there are portions of the theory that are graph-like. For example, the subclass hierarchy. So an object is a kind of physical, an artifact is a kind of object, etc. So you may want to play around with this. It provides these very nice graphical overviews which help you learn the structure and arrangements of Sumo, I think, pretty quickly. Okay, so So next I want to show you some execution at the command line level instead of through the web-based interface. So let's start with just a command I ran earlier to make sure everything was functioning properly. This is very similar to what you see in the README file for Sigma Key. It starts off here. I've modified it just a little bit to make sure that I'm using the right version of Java, the Oracle JDK that I've downloaded rather than the OpenJDK. The next statement is to set the memory requirements for Java, and I give it 7 gig. Sigma does take a fair amount of memory if you've loaded in all of the ontologies and all of WordNet, especially if you're doing some theorem proving. But if you are not doing theorem proving and you're running maybe just the upper level of Sumo and one domain ontology, then you can probably get away with less. But I just, as a matter of habit, since I have a good sized machine, do tend to run with more memory. Next thing you need to do for Java is give it the path to the classes. So all of the classes that we've compiled that are part of Sigma are in the build classes directory, and then all the libraries are in the build lib directory. Lastly, you need to tell it what particular class you want to execute. And so I'm going to show you trying to execute the KB class, which is one of the main classes of Sigma, and I've given it -H just to show you the help screen. So there it is. You've got a couple of different options that you can run. Let's get set up for doing theorem proving. So first thing we're going to do is go down to the vampire section of the Ontology portal Sigma Key README. That gives you a couple of statements to do here, so let's take care of that. Okay, then we need to install G++. Let me fix a typo. I'll fix that in the README shortly. Right, and then with those preliminaries done, then we can actually get a copy of the Vampire code. Now, keep in mind, of course, Vampire is not open source. It has a free license for research, but not for commercial work. So if you use it, make sure, please, that you're using it consistently with the license or contact the developers. So we're going to clone Vampire. Now that the download of the Vampire source is completed, we can go about building it. So let's go to the new Vampire directory. We start off by executing one portion of the make file. Okay, and now we can execute the remaining required portion of the make file. Just get that. There we are. Oh, sorry, not the make file, but rather moving the master copy to be called Vampire. So now we can go through and set the appropriate portion of the Sigma config file to point to it, as well as to E, because we didn't do that in the previous step. So let's do that. So we're going to change to KB's directory, where all of the Sigma data files are located, and we're going to edit the config XML. Okay, so let's find Vampire first. Okay, there we have it. So it actually is already home APs workspace Vampire. We'll check on that. And let's check on E. Now E we actually installed in the programs directory, if you recall. So let's change that, and we'll verify that as well. Programs, and I believe it is E and then prover. Okay, so we'll escape out of that. So let's just double check. Oops. Oh, whoops. Okay. And there's ELTB runner, E large theory batch. That's the version of E that we run because Sumo is so large. There's a special file that controls running E on large files and doing it effectively, and making sure that it doesn't have to reload the knowledge base for subsequent queries. That's a big advantage for a theory as large as Sumo. Other provers do not have that, including Vampire. It did it one time, but it doesn't at the moment. Hopefully the developers will restore that someday. So let's also just take a quick look for Vampire, and so we had pointed that to workspace Vampire. Okay, and we had renamed, okay, there it is, Vampire, large executable, built just a moment ago. Great. All right, so let me make sure that I didn't, I think I kept Java. Yeah, I kept the Tomcat server running. So let's shut that down before we do any more command line invocations, because our memory is limited on this virtual machine. We don't want it to run out of memory. So we do that by executing programs Apache bin shutdown. Before we used startup to start up and shutdown to shut down. Pretty straightforward as long as you know the paths. And you can just save those paths or give it an alias or something. Make life a little easier on yourself. I just haven't done that yet. Right, so now let's try some command line stuff. So let's see if I happened to do that previously. Okay, here we go. So let's try executing E. Okay, so here we are making this call to Java specific to the Java that I just downloaded previously in the previous video. Make sure that I'm not getting the OpenJDK. I'm sure there's a way to set that more reliably. I just haven't looked into what that is. So just rather than the JDK, I want to invoke the Oracle JDK. I want to make sure I have enough memory, so I give it 7G, 7 gigabytes. Point it to the class path, which is the build classes directory, as well as to the build library directory. I'm going to call the KB object, and this option here is for invoking the E prover with a particular query. So let's run that. So all that was just loading the knowledge bases, and now we're loading WordNet, and in a moment then E will actually start. So E is pretty fast. It's actually loading the Sigma system that's taking a little bit of time. Okay, there we have it. Simple execution of proof. Most of the time is actually spent in creating the file that we send to E and in loading Sigma. E only takes just a moment. Of course, it is a very simple query, and we get the answer that there is a region. A region is a subclass of object, and that's already directly in the knowledge base. So it's really just doing a simple match. This is just to illustrate command line invocation. And if you look through the set of classes in Sigma, you can get a lot more information on command line access just by doing help. So for example, if we want to look at KB utilities, we can get a similar listing of help. So for example, there's a utility to generate a simple semantic network by throwing away all of the first and higher order axioms and just taking all of the binary relations that are in Sigma. So if you're doing some sort of graph application, you can still use Sumo. You're just not getting the full power of it as you would by using theorem proving, but that's still better than starting from scratch. So I hope you found this helpful, and see you on the next video. Thanks for joining me on this latest edition of Ontology Talk. If you found this episode useful, please, as always, like, subscribe, and share. And if you'd like more information, you can go to ontologyportal.org and also possibly get a copy of my book. Thanks very much.